First things first, what's a polar coordinate? Polar coordinates are going to be a coordinate point labeled with the radius out and the direction in which it is plotted. Okay, so when you look right here to the right, it is 2 pi over 4, which means it is 2 units out in the direction of pi over 4. Okay, now a polar grid is just what you see here, where it's like there's a regular X and Y axes, but then there's concentric circles that come out from it. So you can see it by the light gray circles. Okay, and so the nice thing about having those light gray circles is because now if I'm going 2 units out, it's not going to be like the grid, 2 units over, 2 units up. It's not like that. In a diagonal, 1 unit, 2 units, we can see it because we have those concentric circles. Okay, all right. So a couple other things. We still measure the angle in which the direction piece of it, the angle in which we are going. We still measure it the same way we have been used to. So starting with a positive x-axis, okay? A couple other notational things, or vocabulary things rather, is the pole is the origin, so the 0, 0 location, and the polar axis is the x-axis, okay? All right, so let's just jump right in here. We are going to plot the point 3 pi over 2 on the polar grid. So this is a polar coordinate, so this is the radius out, and then this is the direction that we're going. Measuring the same way we're used to measuring, where this is 0 degrees. Pi over 2 we know to be straight up, right? This is the direction pi over 2, and we're going 3 units. So this particular coordinate point is going to be 1, 2, 3 units. It is right there. Okay. Next, what happens when they label the R value negative? Well, when they have a negative R value, which is something that's kind of weird because we've never had negative radiuses before. So here's what we do. We go in the opposite direction. So saying -2 pi over 6 is the same. Let me just mark it and then I'll talk to you about how we could say this with a positive R value. Here is the direction pi over 6. And if we go -2, we are going to go 1, 2. It would be this point right here. Now, instead of saying -2 pi over 6, we could say +2 in the direction of 7 pi over 6, because that is where that coordinate is with a positive R value. Okay? So negative R means you go the opposite direction. And we can certainly rewrite polar coordinates many different ways. Okay? As you see here with just 2 different ways. All right, other things that we know. Let's go to this box. We know that the cosine of an angle is equal to the adjacent leg over the hypotenuse. Well, we know that that is the x value over the radius, right? If we're looking at, like, even if you go to your unit circle where the radius is 1, it's the x value over the radius of 1. But we can make it any size, so we can make it as large as we want. It doesn't have to be the unit circle. Well, if you solved it for x, you would get x is equal to the radius times cosine theta. Similarly, we know that the sine is the opposite value over the radius, and if we manipulate, we will get y equals the radius times sine of theta. So because those are some facts that we know going in, we can now take polar coordinates and convert them to rectangular coordinates, which we know are x, y values. So using what we know, and I might just plot it too, just to make it fully concrete in our minds. I am going in the direction of pi over 2, 3 units. My point is right there. I already know by just looking at this that it's going to be 0 for x and 3 for y. Okay, that is my answer. All right, I'm gonna prove it though here. If x is equal to the r times the cosine of pi over 2, then x is equal to 3 times 0. Oh, how about that? We get 0. If y is equal to 3 sine of pi over 2, then y is equal to 3 times 1, and we get 3. Okay? All right, let's practice that one more time. Here we have the r value of -2 in the direction of 0. Well, graphically, the direction of 0 is the positive x-axis, but -2 is saying go the opposite direction. So that's right there. If I want this as an xy value, we are going to have -2 for x, 0 for y, okay? And if I do the stuff in the box here, we will get those values, okay? Those easy ones that you can plot and just see are just that, they're easy. When we go to something like this, it gets a little bit harder. The same idea applies though, so don't overthink it, okay? Sometimes it's easier if we don't overthink. We already know that x is r cosine theta. We already know y is r sine theta. We already know that if we're working on a right triangle, that x squared plus y squared equals the radius squared. And we already know that the tangent is the y over the x, or in other words, the opposite over the adjacent. So let's use those things to our advantage here. We are given the rectangular coordinates x, y, and we want to convert them to polar, which are r theta. So to get a visual here, 1, 2, 3, 1, 2, 3, this is our coordinate point in terms of x, y, okay? So if I wanted, let's just go very lightly here. This is what I'm looking at for a triangle. 3 there, 3 there. I can use Pythagorean theorem to find the hypotenuse. So it would be 9 and another 9. So 18 is the hypotenuse squared. And the hypotenuse is c, which is r, right? That's really, I could have just said this was r, which means r is going to be the square root of 18. We'll find the theta here yet. I do know that 18 is 9 times 2. So the square root is 3 and then root 2. Okay, so that's the r part. Now let's talk about the theta. Hopefully you recognize this when the x and the y are the same. Yes, we have ourselves a 45-degree angle. Let's suppose you didn't know that or you had forgotten that. You would find the theta by tangent of theta is equal to 3 over 3, or in other words, tangent of theta is 1, inverse tangent of 1, if you used your calculator, you would get 45 degrees, or in radians, pi over 4. So my angle is pi over 4, like so. All right. Okay, I'm going to stop there. We've converted coordinate points. Now we are going to, in the next video, we will do equations. Okay, so I'm going to stop this one here.